Hello friends, welcome to my channel once again. And in the last video we have talked about the resonance and sharpness of resonance. So today also we will talk about the same concept. Today in fact we will end this particular article. So if you remember, for a revision purpose within 1 minute we have talked about this resonance. Basically resonance means when we are having exact match of two frequencies. One is the natural frequency of vibration of that body and another is the forced frequency. That means the frequency of a force which is applied externally. If those frequencies are exactly matches, then the body or that particular system vibrates with a maximum amplitude, and that particular condition is known as resonance. Okay, and we have to more specifically talk about the sharpness of resonance. So the sharpness of resonance is defined, or it is determined by one particular parameter. That parameter we call it as response. Yes, if you remember, these all things we have seen in the last video. So the sharpness of resonance is refers to the fall in amplitude with the change in frequency on each side of the maximum amplitude. That means yes, we have to talk about this type of particular curve or a graph at which we are having some falling in amplitude on both sides of a maximum. That particular thing is known as sharpness of particular resonance. Okay, so that sharpness of resonance, for that again we have done some calculations. This is all we have seen in the last video up to the equation number 8. If you remember, we have calculated up to equation number 8. Okay, right. So here by dividing the equation 6 by 7, we got one particular thing, and for that we called it as response. That means the kinetic energy per unit force, which is called as the response, and it is denoted by capital R. And if you remember, after calculation we got that response, equation number 8, as p square divided by mu square p square by m square plus k minus m minus p square, and again it's a bracket square. So this is what the response, and that response will decide what is the sharpness of resonance. So in this equation, or in general, we got this under root k by m is the natural frequency of the system in the absence of damping. That means if the frequency is taking vibrations without damping, right? So without damping, whatever may be the frequency of that particular system, that is under root k by m. It is frequency without damping. Okay, now now see this in equation number 8, the denominator we have k minus m, k by m minus p square. This term, second term in the denominator, that term in equation 8 represents the extent to which the natural frequency of the system deviates from the force frequency. Yes, we have two different frequencies, one is natural and the force frequency. So which term actually decides? So this term, that is k by m minus p square, this term decides how much is the deviation of natural frequency from the forced frequency. That means we know that the body is taking vibration by its own natural frequency, and we are applying some periodic force. So those two frequencies must be matched for resonance purpose. But if we have some little bit deviation, not every time we are getting the resonance, right? We have to wait for some time. We have to do some arrangement so that both the frequencies are exactly matches. So there, or before getting the resonance, how much will be they are deviating from each other, that can be calculated, or that will be decided by this particular term k by m minus p square. And if k by m equal to p square, if this is both these terms are exactly equal, then that will be 0, means k by m minus p square, this term will be 0. So in equation number 8, the second term will be 0. If second term will be 0, then p square will get cancelled, right? Yes, from equation 8, if this second term will be 0, so what we get in the numerator we have p square, in the denominator this term only will survive, that is mu square p square divided by m square. So this denominator will go to the numerator, so it is m square mu square, this p square and p square will get cancelled, and finally what we got is r is equal to m by mu whole square. When it is possible? When k by m is exactly equal to p square. So they name it as equation number 9, and therefore the response R is inversely proportional to mu. Here we can conclude from this equation what we can conclude? Yes, this is what the important conclusion. Response R is inversely proportional to mu. Inversely proportional to mu. Okay, so what is that mu? Mu is a frictional constant. So, or we can say directly, mu is a frictional force. Not force, but it will decide the frictional force constant. Okay, so that means response depends upon the frictional force, because here whatever may be the natural frequency and force frequency, they are becomes exactly 0. That means that term will 0, and at the end or at the last, response will be decided by what? Our frictional force, if the k by m minus p square will be 0. So it means that the response R is inversely proportional to the frictional force, and in the absence of frictional force, the response is maximum. Now let us consider this R is, since we got this R is proportional to 1 by mu, and let us take what we are saying in this statement. If there is no friction means absence of friction means mu is equal to 0. Let us consider mu is equal to 0. Now if this mu is substituted here 0, then 1 by 0 will be infinity. That means R is tending to infinity. R will tend to infinity. That means response will be maximum if there is absence of frictional force. Okay. The term k by m minus p square in equation 8 refers to the mistuning. That is also known as mistuning. Yes, we talked about that. It will decide how much will be the natural frequency and force frequency are deviating from each other. So that we can call, if both the frequencies are matching, then that we can call as tuning. That means if we have some best friend, so we can say, or we will say generally, my tuning with this person is very good. But if we have another friend with whom we do not have that much good relationship, then we can say yes, it is a mistuning. Okay, so that means what? Here that k by m minus p square actually gives you the mistuning, right? The larger its value, the greater is the system away from the resonance. That mistuning, yes, obviously, if I am talking about two different friends A and B, let us consider two different friends A and B. If they are having mistuning, if they are having more mistuning, then is there any possibility to come them together and they will work together? No. If they are having tuning, yes, this mis term should not be there. If they are having tuning, they will come together and they will work as a B. So that coming together and working together, that is what? Nothing but the resonance. Yes, that is resonance. But if we are talking about the term, that is what our k by m minus p square, this is a mistuning term. And if this term is minimum, this term is minimum means mistuning is minimum. Mistuning is minimum means tuning will be there. So tuning means, yes, obviously it is leading to the resonance. Whenever we are talking about tuning, that means tuning of both frequencies. One is natural frequency, another is a force frequency. Then that tuning leads to the resonance. Okay. So the larger its value, the greater is the system away from the resonance. Yes, obviously, if this k by m minus p square mistuning is more, then more will be the chances to not coming together of those two friends. If the mistuning is more, they will never come together. If tuning is more, then they will come together and they will have the resonance and they can work together with the resonance amplitude. Okay. Now, so what that all resonance, response, everything will show by graphical method here. So let us plot the graph between p by omega along x axis. So I have taken along x axis p by omega and response r along the y axis. Okay, so graph here you can see the lines are not exactly straight, just adjust it. So r, that is the response on y axis. Okay, and here p by omega which is on x axis. Right. So if we see here, p by omega is equal to 1. If p by omega is equal to 1, so this center value is 1. So p by omega is 1, then response is going to infinity. That means it is maximum value. Response is maximum if p by omega is equal to 1. But on the both side of this central axis, y axis, you can see the response is going, or response is dies, or response is decreasing on this side also, yes, and on this side also the response is decreasing. That means what? Here we can say response will have the maximum value when p by omega is equal to 1, and on both sides, so response decreases as p by omega is less than 1 or greater than 1. See here, on to this side it is greater than 1 and to this side it is less than 1. So whether it is less than 1 or greater than 1, response will be decreases. Only when p by omega is exactly equal to 1, then we will have the maximum value of response. Now for curve A, we can see for curve A, this curve is having less response. So that means here more is the value of mu. Mu is greater. Mu is more, we can say. As now if we are talking about these three curves A, B, C. So in this we can say for this curve A, the mu, that means friction, is more, and for curve C, the mu is less. Yes, by the graph only we can see less is the mu, maximum will be the response. We know that because response is inversely proportional to mu. So for curve A, we have more or maximum, we can say maximum, sorry, we cannot say maximum, but greater we can say as compared to A and C. If we are talking about the curve A and C, then if we compare them, for curve A we can directly say, because here the response is less as compared to curve C. So response is less means mu must be greater, or vice versa. In reverse manner we can say, as this mu is greater, this response will be lesser. So as this is for curve A. For curve C, as compared to curve A, response is more. So response is more. When the response will be more, if this mu will be less. So this is what we can say one term, and this is what the other. If greater the mu, less will be the response. If less will be the mu, greater will be the response. So this is what just comparison between A and C. And for B curve we have the intermediate mu, and that's why we have intermediate response also, right, as compared to A, B, C. Okay. Now when the frictional forces are absent, that means when we say mu is equal to 0, already we talk about this point, mu is equal to 0, that means obviously because R is inversely proportional to mu and mu is tending to 0, that means this R will tend to infinity. We will have the maximum sharpness at that particular condition when mu is equal to 0. And as mu increases, obviously as mu increases, the sharpness response is, see here, R is inversely proportional to mu. When we say mu increases, that means R is decreases or R is decreasing. R decreasing means ultimately what is decreasing? The sharpness is decreasing. That means if we have more friction, then we will have less sharpness. Yes, we have less sharpness, or vice versa. If we have less friction, then we will have more sharpness of resonance. And the sharpness changes rapidly for a smaller change in p by omega. By looking at the curve only, you can see here, see from the value of p by omega is equal to 1, if we change slightly, because at the p by omega, this curve D, it is going to infinity. Okay, if p by omega is exactly equal to 1, it goes to infinity. But as we change little bit, now from this point to this point, we did not change in that much way of value of p by omega, but at this point, here you can say the response is decreases very rapidly from infinity to it will come to the curve C. Now if again we talk about a little bit change corresponding to curve C, so this will be the rapid change or rapid decrease in our response. So here this is a very rapid change, but we change the p by omega value very small manner, in very small manner. So in short we can say for a very small change in p by omega, we will have very rapid change of response, and ultimately when response will have the rapid change, so we can say the sharpness of resonance will also have the rapid change. So this is all about the sharpness of resonance. In the last video only we have done everything, but what is some theoretical aspect or this graph we have discussed in today's video. Okay, so thank you friends. If you have any doubt, you can post in the comment box, and if you feel this is a value addition to your knowledge, then you can like this video, and if you want more such videos for your knowledge purpose, then please subscribe to my channel and press the bell icon, so that as soon as I will post the next video, you will get the notifications. Okay, so this is all about today's video. It is simply the continuation of last video, sharpness and resonance of sharpness part 2. Okay, thank you very much, and we'll meet in the very soon in next video with a very interesting concept. Till then, you will just study well, and yes, take care and keep learning. Thank you so much.